Okay, so we have an axial bar which is, this is a question from machine design. We have an axial bar which is subjected to loading, and this loading actually is something like a cosine loading. So versus time, it varies like a cosine loading. Okay, it just keep on varying, and this is given as f naught sine f naught cos omega. That's why I have drawn a time 0, a higher value, because cos 0 is 1. So this is the loading, and from this we will come to know that the mean load is nothing but 0, right? The mean load is 0, and the variable load or the amplitude of the load is f naught, right? The amplitude is f naught. Okay, so obviously from this the mean stress would be mean load by area, so it's 0, and variable stress, let me denote something for the mean stress, sigma mean, and variable is sigma v, which is variable load by A, which is f naught by A. Okay, now what he says is you need to estimate such that there's a failure by Soderberg. Now Soderberg, if you remember, is denoted by this line, where on the x-axis you are plotting the variable stresses, on y-axis you are plotting variable stress, on x-axis you are plotting mean stress. So the point where it fails on the x-axis is the yield strength. This is Soderberg line, and the point where it fails is the endurance strength. So if you are on the line and above that there is a failure, within this line you are safe. So point on this line, now the equation of this line is sigma x by a. I mean, the equation of this normal line is x by a plus y by b is equal to 1. X by a, what is x? X is mean stress, a is the intercept, which is sigma yield, plus y is what you're plotting on the y-axis, sigma variable, b is your endurance limit, is equal to 1. I mean, that is the equation of this line. So we need to predict the f naught such that there is a failure by Soderberg criteria. That means it is just on the line, and the tendency is for the stress to go above it. So we take this case, the mean stress is 0, sigma yield is given in the question, but that's I think not useful because the numerator is 0. The variable stress we got f naught by a. The endurance is given. Let's look at the value of endurance. Endurance is given as 200 MPa, so that is 200 MPa is equal to 1. So from this, f naught is 200 into a, which is 200 into, so it's predominantly dominated by endurance. You have a point somewhere here, into pi by 4 d square. So 200, diameter is given as 25 mm, so that is 25 mm whole square, and so this is in MPa and mm square. So what you get is Newton, and when you divide it by 1000 we get 98.1 kilonewton. So f naught is 98.1 kilonewton. Let's look at, so this is this much amplitude of the load if you apply in that f naught cos 50t. This is the limitation on the amplitude. 98.1. Let's look at the option 98 point. So it's B. Thank you.